Hello everyone and welcome to Keeping Tabs on Chemistry. In this video we are going to be talking about reaction rates. So reaction rate is the time it takes for a reaction to occur. So for a reaction to occur, two things have to happen. Molecules have to collide and those collisions have to have enough energy for the reaction to occur. Kind of think about it as if you're walking down the hallway. Right? There are two people walking down the hallway. They may not particularly like each other. There's going to be a fight. Right? But in order for that fight to happen, right, if you're just passing by somebody unprovoked, you're not going to fight. So somebody is going to walk up and, like shoulder check them, right? There's been some sort of collision, right? So now we're getting ready for a fight. Now that shoulder check, it couldn't just have been, rush hour traffic in the hallways, you just kind of brush by somebody. That's not enough intent, not enough energy for that fight to happen. You got to have clearly, really slamming into them. So you have a collision and that collision has enough energy, now you're going to have a fight. Same thing for reactions. The molecules have to collide, they got to collide with enough energy. So the factors that affect reaction rate are surface area, concentration, mixing, temperature, and a catalyst. Right? So we're going to talk about each of these and how they change reaction rate and why. So you can increase surface area by crushing a solid. So the least amount of surface area is, say you have a sugar cube, whereas the most amount of surface area is when you have powdered sugar. So increasing surface area is going to increase reaction rate because there are more molecules available to collide. Thinking about it this way, this is our sugar cube. The hydrogen ions on the outside, those red particles on the outside, can only react with the particles that are on the very outside of this molecule. The ones on the inside of the clump here, those are protected. Now, if I were to break it down, all right, increasing the surface area, now these red particles can get in between and I've got much more available particles to collide with. Right, so it's more likely to react because there's more likely to be a collision. The next one is concentration. Increasing concentration also increases reaction rate for the same reason. There are more molecules available to collide. Right, so the idea is with our green particles here, just a few availables to collide with, right? Not very likely. The more I have, the more likely they are to bump into each other, right? I'm more likely to bump into somebody in the crowded hallway than when it's just the two of us. For mixing, right? Mixing increases reaction rate because there are more collisions. Right? When I'm moving faster, I'm more likely to run into something else. Think about it this way, you're standing in the classroom. If I ask you guys to walk around the room, it's pretty easy to avoid each other and the desk and the chairs, you know. But if you're running around the room, you're much more likely to come in contact with something else, whether intentionally or not. All right, temperature. Now remember, temperature is a measure of kinetic energy. We've been talking about that since the beginning of the year. So increasing temperature means that my molecules are going to move faster. So we are increasing reaction rate because the molecules are moving faster and there are more collisions. This is just like mixing, but instead of physically mixing it up, I'm having the molecules moving faster through temperature. Right, same idea. The last one is much different than the others, right? Catalyst. You've talked about catalyst before in biology when you learned about enzymes. So adding a catalyst increases reaction rate by lowering activation energy. Now, remember we've talked about reaction coordinates before when we learned about endo and exothermic reactions. I have my reactants here. I have the energy of my products after the reaction. Now there's this hump here, right? This hill, right? The amount of energy it takes to get to the top of this hill is the activation energy, right? So up at the top we have the transition state, or what we call the activation complex. Right? So this is the energy I have to put into breaking bonds before I can remake them. Right? So like breaking a pencil takes energy, I have to put energy in to break bonds before I get energy out by forming new bonds. So this activation energy, when I add a catalyst, I'm taking this hill and I'm making it lower. I am lowering the activation energy, giving it a different path to follow. It's going to take less energy to cross over that hill to form the products. Now notice the energy of the reactants and the products has not changed, just the pathway I took to get there. So this is what enzymes do, right? All catalysts. Now, not all catalysts are enzymes. There are other inorganic catalysts we can use. Platinum's a really common one in chemistry, and palladium. Uh, but they all work in similar ways, lowering the activation energy. So, activation energy is the energy needed to reach that activation complex, the transition state. It's related to the energy needed to break the bonds in the reactant molecule. So we're taking that hill and we are lowering it. So what this means in terms of reaction rate is I have moved the goalpost closer to me. Right? So I'm having the same number of collisions that have the same amount of energy, but now less energy is needed for that fight to happen. Right? You got somebody who's really angry, had a really bad day, right? And any contact with them, right, even if it's innocent, just a brush on the side is going to set them off, right? That is what a catalyst is doing. So, in summary, right, by increasing surface area, by crushing, we are increasing the number of collisions, which increases reaction rate. Increasing concentration also increases collisions, increasing reaction rate. Mixing, so more mixing means more collisions, which is an increase in reaction rate. A higher temperature means higher collisions and higher energy, so a higher reaction rate, increased reaction rate. Adding a catalyst lowers activation energy, which increases reaction rate. And that is my summary on reaction rates.